Thank you very much. I appreciate being here. It's a lovely building, I have to say. So yes, my name is Sigray, and I've been doing research now for many, many years on underwater sound, 15 years or something like that. And actually it was partly me who started the research in Sweden, at least, on this topic here. And I will try during these 20 minutes to give you an impression of underwater sound, because it's very different from atmospheric or this room kind of sound that we are here. I would like to just give an example, a very, very interesting example, and this is a colonization of coral reefs. And it's about 5 years old, this 2010, yes, it's more 10 years old, this result here. And what you see here on this side is the actual experiment. There are some plastic cylinder here, and there is a hydrophone, that is an underwater microphone measuring the underwater sound. But if we jump to the left side here, you can see that there was a loudspeaker insonifying this plastic tube. And the sound coming out here was coral reef sound. And you see that there were several of these, and they were placed on pretty sandy bottoms. So it's not a coral reef here. So some of these cylinders were sonified with non-coral reef sound, and some of them were sonified with coral reef. And the small larvae, they were settling on the tubes that had sound from coral reefs. So even these small eggs, larvae, they are floating around here, and then they are listening to, am I at a good coral reef? Yes, let's settle. So they know it, they know where to go. So what I'm trying to say is that, look, I mean, nature is fantastic. There's so many aspects. Now what we're going to talk here today is not just a fantastic natural sound. When I say sound is something that should be there, we're also going to talk about noise, something that shouldn't be there. Then I usually use this graph here showing the hearing, and on the x-axis here we can see frequency. This is very low frequency, about 10 hertz. This is approximately where human can hear, and this is up to 10 kilohertz, and then it's 100 kilohertz and 200 kilohertz. And we can see that eel, cod, perch maybe, seal, bottlenose dolphin and whales, we can see that they all have hearing. They can hear in the oceans. And we can also see that all the stuff we humans are doing is producing sound in the same frequencies. So there's an overlap between what they can hear and what we produce. This is somehow the first step when we're going to try to take care of underwater sound. So maybe we have a problem here, that is overlap between what we are producing and what they can hear. Then comes the question, but is there any indication that there is a problem at all? And there is, of course, some indication. I'll show you these two graphs here on the lower part of the slide. And if you look at the left part here, you have 1955 up to 2010. And these are measurements done outside California, and you can see that the ambient sound is slowly raising all the time. About 0.5 decibel per year has an increase. And if you look at this graph here, you have date from 1955 to 2000, shows the shipping, the commercial shipping, and it's the same kind of increase. So there is most probably the sound increase in the sound is due to commercial shipping. So what we're seeing here is the continuous noise. There is always a hum around in the oceans due to shipping. And then we have the other part here. We see a windmill here, a drawing of a wind turbine. And these are enormously, 90 meters high here, and there's a pile that is buried or piled down in the sediment about 30 to 50 meters. And when this pile is being driven down there, they use a big hammer, which is just hammering, boom, 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 boom. And it's produced an enormous amount of sound, noise in the underwater environment. And as you know, in the North Sea, we are hammering all the time. at the moment because we want to have wind turbines, but it also poses maybe a problem, this kind of sound. Just a quick one that Matthias and I did some year ago, showing that the green one here is what you get. Okay, this is decibel now here. 60 decibel, 100 decibel, 140 decibel. And this is how often this decibel occurs in the Baltic Sea. And the green one is how it should be if there would be no anthropogenic activities. And the blue one here is when we add the ships. So there's quite a big difference between when we have human activity and when we don't have it. So I think I convinced you now that there might be a problem, and I think I ask you to start it. And this is a simulation just showing. The next question you have to ask, okay, ships are a problem, but how many ships do we have? And this is simulation. This is the Bay of Finland, and we're going out in the Baltic proper. 2012, you can see the hours spinning up here, and you can see all the ships everywhere here. And I think this is Gotland coming up here. And then you have Öland here. There's ships everywhere in the Baltic Sea. So maybe we have noise everywhere in the Baltic Sea. And I just continue here. And what we did was that about 5-6 years ago, we had a project where we were deploying, putting in these underwater hydrophones into the Baltic Sea. All these dots here shows where we have been measuring. So we measured for 1 year all the underwater sound, and then we got a map. And this is the first Soundscape map of underwater noise for the Baltic Sea. And I would say also it was the first map in the world over such a large area. And you see here 60 dB, 132 dB is dark red, and it's really red around some areas here. And it's not just red around the point where the ship is, it seems to be red everywhere. And the reason for that is that underwater sound is trapped in. It's very much trapped in the water, it cannot escape. So usually when I have students, I ask them, why don't you, when you put your ear against the water, why don't you hear anything? For a very long time, that was what people was doing. Like, no, they don't talk, there is no noise, there's nothing in the water. But actually, if you look in a normal mirror in the morning, the reflection of that is 80 to 90%. So 20% is passing through the mirror. Despite of that, I think you think that's a really good picture of yourself. However, when sound goes up to the surface, 99.99% is reflected. So everything is locked into the water column, and it's reflected down to the seabed. And the seabed reflects it, and it reflects it. So it's just bouncing around. It never dies. And that's why we get this red everywhere. So coming in then to a little bit to underwater sound, and I'm going to talk a little bit about soundscape, because that's more what the animals are interested in, or what they perceive is the soundscape. But we have to understand a little bit what's happening in the water. So we have this nice picture, we have a ship, we have some mammals here, and we have one of our sensors down here. And as I said, they are emitting sound which is bouncing around. And one thing that is a big difference between air and water is the speed of velocity. It's 1,500 meters per second. It's much faster underwater. So if we go down, we cannot really process direction with our ears when we are diving. Decibel in air is not as decibels in waters. What I showed you there has nothing to do with air decibels. I think everyone knows that 120 dB is really bad for your ear. But 120 dB in water, it's loud, but not that loud as in air. And I already have been talking about is that water is locked between the two surfaces. So it just spreads. You can't get rid of it. And I also showed you here that we have impulsive noise when you're banging or explosions. And we have continuous noise like ships. So these are the two things. And my colleagues here, they will give you some examples of how it should sound like when you are in the ocean. And I will just continue, and I have a palette of some of them, and I'm going to ask you to start the flash. How does lightning sound like? And you can hear the echo, which is called reverberation underwater. So it's bouncing around everywhere. What can we take more? I think we should maybe take rain. Take this one, and then I stop. Well, if you go back and try to take the rain. It's like a carpet of noise. It's not noise, sound, sorry, wrong again. It should be there. So these sounds are naturally occurring that you see here, and they should be there. So the pristine state is not that you don't have any sound. Now we come to human intervention, and we can start the left one here. See, this is piling. And this is pretty far away from the piling, actually. And this continues day and night during the whole year in the North Sea. And we can start the other one, and that's, I think, is a sonar. And this is also pretty loud. And I actually show that usually when we say sonar, people think about the marine, the navies, but it's not just on the navies. This is Oden. Oden also have a huge sonar in the front that they are using for the benefit of increasing our understanding of the planet, actually. So all these things are there all the time, and they mix up with the natural sound, and it's gets pretty messy down there sometimes. Then comes the next question: does it matter that we have sound there? Do the mammals and the fish, do they really use it? And this Richard Fay article from 2009, he's actually writing, it's a mystery, because sound is always, when we talk about land animals, it's about somebody sending a message like I'm doing now. There's a sender and you are the receivers. But we know that the goldfish is not saying anything, so does it really use the sound? So that was kind of a mystery, and he made a really interesting and genius experiment where he trained a goldfish. They're not stupid goldfish, you can train them even. He trained it to tell him when he can hear an echo from white noise. That's very technical. But can he hear white noise echo? And he could. The goldfish could hear it. And why do you need to be able to hear echoes? Well, you are hearing echo now. If you close your eyes, you can immediately say where I'm standing in this room because you are using the echo in the room. So that's why, because they are predators. They have to hear the predators if they are sneaking up behind. Because then there is a reflection in the room that was not there before it came. So yes, animals like fish, I'm giving an example here. Mammals, we will hear, are even better when it comes to hearing because they're more like humans. They are using this information. And just very quickly to make you understand the fish has like 3 hearing. They have some of them have a swim bladder. And the ear, which you see here, it looks very much like a human ear, is connected to it, so they can detect the pressure differences like we are doing. But they also have an otolithic stone here, so you can also feel the motion in the water due to underwater sound. And then they have the lateral line here at the side. So they have 3 ears, so to say, that they are using. And we just have 1. So they are living and they're really perceiving their environment. So they are really having an understanding on, even if it's dark, what does it sound like in my room? And Soundscape was actually first really raised by Southworth, and this is actually came from art. They were more into it in the beginning. What is sound in a room? So before science even started to look into this. And they started, what is sound in a room? And they started to categorize it. And let's see. Can you hear it? If you close your eyes, you can see this. This is Soundscape. Oh, sorry. Something came in there that shouldn't be there, and you immediately recognize it. And this is the problem with it. What I said was, the problem is underwater that it's masking the communication, is masking the hearing of the animals if you have ships everywhere. I found this web page. It's really nice. It's called naturesoundmap.com, and it's the whole world, and people can put in sound recording here for nature, and I really recommend that you go there. Soundscape is something more than just the natural soundscape, because everywhere today we have humans. So there's a soundscape pattern. There's a natural sound like wind, waves, lightning, biology, and then we have humans. And this plays an intricate, intermingled these three different boxes, they are somehow interfering with each other. And actually what happens is that the animals, they either adapt to the soundscape. They can raise take down their voice, they can go up with their voice a little bit, or they can actually morphological adapt, and that takes a little bit longer time. They change how they actually looks morphological, or a niche effect. A niche effect is that I'm not going to talk here in rush hour because nobody hears me. I'm going to give the talk in the night instead. So there are already. I mean, the animals have a strategy to counteract the human intervention into the soundscape. And I think I stopped there. Thank you very much for your attention.